Mind to all of you, our second test will be on this Saturday, 9 p.m. At I think P16. Tak ingat lah nama blok dia. P16 P16 exam room. Okay, 9 p.m. until 10:15 p.m. Okay, so as promised, so we will go through in brief about the three-phase inverters, maybe around 45 minutes and so on. And after that, we will go for the next subtopic, which is the AC motor drive. Okay. Even though this three-phase inverters is not in your final exam, but the questions related to these three-phase inverters will be inside your question, which is the AC motor drive. Okay.
Excuse me, doctor. Doctor.
Yeah.
Yes, doctor. What are the contents of the final examination for this course?
Sorry.
The final exam. Like, what's it gonna include? Everything after test 2?
The final exam. The content of the final exam. We will discuss this after maybe next week.
Yeah, it's because like doctor, you know, like for the power systems and drive, it's actually in the reading week. It's actually on 5/7.
Yeah, I know.
Yeah, so the time is a bit tight, basically. It's very tight.
Yes. I'm
Like
noting on that.
Yeah,
But we don't have any option.
Yeah. So
Okay?
I just hope like the contents are like after the test 2, basically. Hopefully, it's gonna be better. So,
Okay. Sorry for that because I cannot hear you clearly. Okay?
No worries, doctor.
Okay, so saya tak pasti you punya sekawan ni. Okay, tapi itulah. Okay, they try the best. Ni macam mana saya nak hilangkan ni Nak hilangkan yang atas ni. Susah juga ni. Baru nak turun. Okay, three-phase inverters. So for three-phase inverters, so the circuit is this one, which is general circuit. We have 6 switches, okay? And as you can see, all the numbering of the switches for the upper groups are in odd numbers, while the lower group are in even numbers. Okay, and the loads usually it can be either star or delta connection. Okay, but for the low, usually this inverter is used in what I call medium power applications. So usually the loads connection is actually in what we call a Y connections lah, which is star connection. So Y connection, and as we know for Y connection, V line is equals to V line is equals to square root 3 V phase, and then the angle is positive 30 degrees. So this relationship you need to remember, and I line is equals to I phase. Okay, this is for Y connection. So our syllabus will be concentrate on Y connection only. Okay. So the switching schemes can be either square wave or pulse width modulation. Okay, so this is the simplest switching, which is a square wave. Okay, and as you can see, we have 6 switches. Okay, and then we have a 6. Okay, 6 switches, and we have 6 signals kat sini. Okay, and then this one is actually one period, one period. So meaning that, and then this is 50%, 50% on, 50% on, 50% off. Okay, one period. So this one T on 50%, this one also 50%. So even, on and off is even. Okay, and as you can see, for the switch that are in same leg, okay, for example, leg 1, we have S1 and S4. Both switches cannot be turned on at the same time, meaning that if S1 is on, S4 must remain off. Okay, so you need to make sure that when you design the switching, make sure that when S1 is on, S4 must be off. Okay, as you can see here, S1 is on for this period, S1 is on, so that and then as you can see, S4 is off. So make sure that for switches that are in the same leg, they cannot be turned on at the same time. Turn off, no problem. Kalau dua-duanya off, no problem. Okay, but you need to make sure that S1 and S4 must not turn on at the same time because it will be short circuit. Okay, short circuit meaning that you turn on S1 and you turn on S4, so the current will be here, will be looping here. Berapa agaknya current dia? For example, this one 5 volt lah, 50 volt. For example, 50 volt. What is the current that will flow inside here? If S1 and S4 ni you switch on, you accidentally switch on at the same time. Berapa agak current? Dia punya voltage 50 volt. Ada resistance tak kat sini? Because you kena pakai ohm kan? VIR kan? So current is actually V over R. So right now R tu betul. Okay, R tu kosong Infinity lah. So the current can be infinity even though the voltage source ni 5 volt. Okay, jangan main-main Walaupun 5 volt, bila short circuit, current can up to 1 kilo amperes. Can be anything. So that yang teruk lah, memang bahaya. Okay. I have one case which is actually I accidentally short circuit a circuit which is for electric vehicle, a battery. Dia punya value is actually I think around 60 volt je. But accidentally kita tak faham, we didn't understand the circuit because the circuit is actually developed by the other party. So I accidentally turn on or connect that terminal and meletup lah. The battery. Okay. Battery tu dah start meletup lah. Because lithium ion is a very dangerous battery. Lithium ion. So you compare lead acid and lithium ion is the most dangerous battery. So kena berhati-hati. Okay. Okay, so this is the output voltage. As you can see, this one is the VAB, VBC, and VCA. So this one is your V line to line voltage. Okay. And as you can see, we have this one between this adalah 30 degrees because dia sebenarnya every segment ni dia time interval ni 60, sorry. Dia punya time interval 60 degrees sebab every one period ni dia bahagikan divided the time ni, okay, one period ni to 6 segment 6 segment. So semua tu ada 6 segment. So maknanya this one 60 degrees lah. Okay, each segment 60 degrees. 1, 2, 3, 4, 5, 6. Okay. Okay. Contohnya for this one to this one cycle one cycle. So this one 60 degrees. So this one also 60, 60, 60, 60 and 60. Okay. Divide into 6. Okay. So this is our V line to line waveform. And this one is your V phase waveform. So this one is your VAN, VBN, and VCN. And as you can see, the waveform is not similar with the V line. You can see that it has what we call 6 levels. We have 1, 2, 3, 4, 5, 6. 6 steps. Okay. So that's why sometimes this kind of circuits using square wave, it called a 6-step inverters, because the V phase is actually has 6 step output voltage. Okay. And each step, the magnitude is 1/3. Okay. Itulah, kalau online ni susah nak lukis Dia punya magnitude ni is actually 1/3 VDC And this one is 2/3 VDC. Okay. So each steps to 1/3 and then the other one is the 2/3. Okay. So this one is your V phase. So by comparing the waveform of V phase and V line here, which one that you based on your opinion, which is the waveform that has less harmonics distortion? This one is your V line. This one is your V phase. Which one, in your opinion, has better harmonics content? Meaning that lower harmonic content. Which one that you think? The V phase or V line?
V phase. V phase.
V phase, Why V phase?
Because it's not as smooth.
Because, okay. So actually, when your waveform is near to sinusoidal waveform, resemble very near to sinusoidal, then meaning that the waveform has lower harmonics. Okay, so if compare V phase and V line, which one has the nearest waveform to the sinusoidal? Of course, V phase. Okay. So senang lah kalau nak tahu dia punya voltage ni ada harmonics atau tak ada. Dia tengok waveform dia hampir-hampir sama dengan sinusoidal pun tak. Okay. So dalam inside the power system engineering, okay, dalam banyak-banyak waveform square wave yang paling teruk sekali dia punya distortion. The highest harmonic distortion is actually inside square wave. Okay. Triangular nombor tak tahulah, tapi triangular is not the highest lah. Dia ada banyak macam waveform kan. Tapi jangan pula dalam you punya control and signal, you belajar nanti control system, you ada triangular waveform, you kata oh banyak harmonics. Jangan pula cakap macam tu kat you punya lecture control. Kan kita punya signal control ni main pulse Actually you playing it pulse kan, on off kan. Jangan pula you cakap oh betul ini banyak harmonik ni. Memang kena ketuk lah kepala. Okay, harmonics ni is actually refer to the system lah, power grid. Okay, harmonics is only relevant to power grid. Tak relevan kepada you punya communication signal ke, communication signal tu macam banyak. Kan? Jangan kata you punya oh signal ni banyak, communication ni banyak harmonics, banyak gangguan, banyak interference. Memang pelik lah. Okay. Tapi ada juga nanti yang buat dalam thesis nanti. Yang mana yang ambil dengan lecture com, ada dalam thesis, waveform, oh banyak harmonics. Jangan harmonics is actually relevant to the power grid. Power and energy. Okay, so as you can see, we have the step or the level is 1/3 VDC and 2/3 VDC. Okay, how this can be calculated? Why? Macam mana? Why we have this 1/3 VDC? Why can this happen? So this one slide explain why can we have that values. For example, when from 0 to 60 degrees, interval from 0, dia punya interval ni from 0 to 60 degrees, which is the first interval ni, kan? Okay, the first interval S5 and S6 and also S1 will turn on so based on this punya configuration, then you need to redraw, okay? So which is I have drawn this one. So you will see that this one is the VAN VAN. The voltage appear across VAN is VDC over 3. That's why I have my VAN is 1 over 3 VDC here. While for the VBN, so this one is your VBN, the voltage across this VBN is negative 2 VDC over 3. Okay, so that's why my waveform for VB for this first interval, 60 degrees interval, is actually negative 2 over 3 VDC. So this is actually depends on the interval. So for this first interval, S1, S5, and S6 will turn on. So you need to look at the current part, the voltage, polarity, and so on. So you will see that what the reason why we have VDC over 3 and negative VDC over 3. So this one is for the second interval and so on. So I think I will don't want to elaborate more on this. So you can refer to the slides. So this one, and this is the Fourier coefficient for the line voltage. So this one is for the line voltage, the first equation, which is this one. Okay. So Vn line to line, meaning that referring to the harmonics voltage. Okay. And this is for the phase voltage. Okay. So this one V phase, V phase. This one is your V line. Okay, and the numbers n here is actually starting from the fundamental, which is the desired voltage with component, and then start with 5, 7, 11, and 13. And as you can see, this is all odd numbers, but all triplet harmonics, which is the number that actually in gandaan 3, all missing. Okay, missing. So 3, 9, 15, apa lagi? 3, 9, 15, 21. Oh, 18 18, and then 31 kan? So anything that actually triplet, the factor of 3 will be 0. Okay? Why? Because as you can see, if you put n is equal to 3, you will have 90 degrees. So cos 90 is 0. So that's why all triplet or harmonics that is actually in the factor of 3 in a three-phase system will be disappeared. So that is one advantage of the three-phase inverters. It will automatically eliminate harmonics with a factor of 3. Okay, so this n is actually starting with 1 and then 5, 7, 11, 13, and so on. Okay, so this is for the line voltage and this is for the phase voltage. Okay, this one I can skip this one. Okay, and then the THD, the equation for the THD is same, which is this one. The upper part here is the summation of all harmonics waveform in the RMS values, but the numbers is starting with 5, 5, 7, 11, and so on, and divided by with the V fundamental. And this is for the load current and so on. So I think this one is actually same with the single phase PWM. Single phase inverters, Only the number, starting with 5, 7, 11, so on. For the single phase, we have 3, 5, 7, semua odd numbers. Okay, and then this is using PWM, So using PWM for, I think maybe you can recall what is the advantage of PWM compared to the square wave. What is the advantage? There are two advantages. What are the advantage? The first one is Yeah, it can control the V fundamental. Okay, square wave we cannot control the V fundamental because it's already fixed. So by using PWM we can control by controlling the modulation index MA or MI. The second one advantage is we can remove the harmonics at higher frequency. Okay, we can remove all the harmonics at the higher frequency.
Lower power consumption, doctor.
Yeah, okay, can be accept, but that one is not a major advantage. Okay, the major advantage is we can control the fundamental, and the second one we can actually shift all the harmonics at the higher frequency. And the PWM, the harmonics is actually appear in the cluster. And the first cluster frequency depends on your switching frequency. So meaning that location of your harmonics depends on the switching frequency. So meaning that if your switching frequency is 20 kilohertz, meaning that the first harmonics will appear at 20 kilohertz. Okay. So by removing all the harmonics at the higher frequency, then your design for the filter can be very, very easy. But the disadvantage of using PWM, I think same with the single phase PWM inverters, you required a very what call high performance microprocessor. Okay, if you are planning to use for example Adreno so it's impossible. Okay, so you need to use either a DSP or FPGA and so on. Okay, this is actually the switching technique. Okay. Okay. There is one advantage, another advantage for the PWM. Okay. If you are frequency triangular, with your frequency carrier, FC, or frequency triangular lah, ataupun sama dengan frequency switching, frequency switching is actually same with the carrier frequency. So if your frequency switching or your carrier frequency is in the factors of 3, okay, maknanya 3, 9, 15, so all the harmonics that is odd, triplen, multiple of the reference frequency will be automatically eliminated. Apa maksud dia? This one, So this is the harmonic spectrum for V line, This is the harmonic spectrum for V phase, So if you are using your frequency carrier is in the factors of 3, for example, 3 multiply with the switch modulating frequency, sinusoidal, Okay. 3 ataupun apa? 15, apa lagi? Sorry, 9, 9, 15, apa lagi? 18, 21, 21, So this one is actually all these numbers 21, 18, 15 ni is actually your modulation ratio sebenarnya. Kan? Sebetulnya 21, So this is actually the spectrum when you choose your frequency carrier is in 21 multiplied with FM, which is MR21 lah. So which is 21 is the number dalam gandaan 3 kan? The factor of 3. 3 multiplied with 7, right? You got 21. So if you choose 21, as you can see, all the odd numbers and triplet numbers of the harmonics will be disappeared in the line to line voltage. For example, this one is your V phase. you can see for the V phase, you have harmonics number 21. But at the line voltage, the harmonics number 21 is eliminated. Same case goes to all the harmonics that are in the factors of 3. For example, 39, apa lagi? 45, dan sebagainya. Okay? So meaning that if you choose your MR dalam keadaan 3, all the harmonics dalam keadaan 3 semuanya hilang. Dalam line to line voltage. Inside line to line voltage, all the harmonics will be eliminated. Okay? And as you can see here, in the line to line voltage punya waveform, spectrum is more cleaner compared to the V phase. V phase ni banyak sangat kan? Untuk line to line ni, makin sikit. Okay? Kalau contohnya for the class, this cluster, compared to this cluster kan? So as you can see, the line to line punya waveform, harmonic spectrum is much cleaner. Okay? So example kat sini saya boleh stop record. Okay. So this is example 1. If you want to have a macam nak buat revision and so on, so you can try this example. The solution is there. Okay. Kalau you print memang tak nampak solution. Okay. You print memang tak nampak solution. You need to maybe pakai komputer lah dapatkan ni sebab dia animation kan. So we have give you the solution. All the values are there. So you can double check. Okay. And I think that's all for the 3-phase inverters. Okay. So we may take a break. About maybe 50 minutes. Okay. Before we proceed with the AC Moto Drive. Okay. 50 minutes. Berapa ni? 15. 40. Boleh lah pukul 12 eh. At 12 we will come back. But before that, sementara tunggu nak ni, so I have shared with you the video kan. That video, I think for those who have took my class, Fundamental Power SEE 2423, I have also shared that video. That video is actually all on the fundamental concept of the 3-phase induction motor. So I will not go deep to revise that in our slide. So what I want you to do is actually to look at the video first, and then maybe from that you can have regain balik you punya knowledge lah on that. Okay. So because at that for that motor, so kita sebenarnya for this syllabus kita nak apply saja, kita nak guna saja. Kita tak nak tengok synchronous speed tu apa, kita tak belajar benda tu. So that one should be learn dalam course yang lain kan. Okay. So before, but tapi lah sebelum nak pergi ke drive tu, you need to actually dapat gambaran sedikit lah, refresh balik. Okay. So boleh tengok tu juga, and then pukul 12 nanti kita start balik. Okay, so this is actually the last topic for our course, which is the AC Moto Drive. Okay, kenapa pula jadi macam ni? Okay, so we have divided it into 2 parts. So this one, part 1 is more on the theory lah. Okay. So this one I think we skip here. And as you know, we have for the rotor, we have stator and rotor. So the rotor structure we can have 2 types, either squirrel cage rotor or one rotor. Okay, and then this is the most important equation that you need to remember. The synchronous speed. So what is the synchronous speed? Is a speed of rotating magnetic flux. Dalam ada lab mesin kadang selalu saya suka tanya. Lab mesin siapa student under my supervision, I always ask them, what is the synchronous speed? Can it be measured? Tak boleh lah. Sebab it cannot be measured, it can be only calculated. Tak boleh. Okay. So that is actually the magnetic punya rotation tu, flux tu. Dia berpusing dekat stator. So the numbers the speed is actually can be computed based on this equation. 120 multiplied with the frequency supply. This one is your frequency supply, okay? Versus P. P, this one is the number of pole. So if you have, for example, north, and then you have south. Kat sini pun ada north, kat sini ada south. So meaning that this one is 4 pole, 4 poles. There is also another equations that sometimes depends on the textbook. So you can find the synchronous speed is equals to 60 multiplied with frequency supply over P also. But this P, the definition is not the same. This P is actually pair of pole. Okay, so don't be confused because these both equation are actually will result in same values. But please be remind on the values of P. If you are using this equation 120 multiplied with frequency supply over P, this P must be the number of pole. If you are using this equation 60 multiplied with frequency supply over P, this P is actually not number of pole, but is actually the pair of pole. Okay? So please be remind on that. So this is number of pole is 4, but the pair of pole for this configuration is 2 pole. Okay, 2. Sebenarnya sama je lah kan? Sama je. Okay, so jangan please being confused. Because nanti you jumpa textbook dia pakai ni 60 frequency supply over P. Okay, nanti you confused. And actually that P definition is actually depends on the textbook. Okay, so that one the unit is in RPM, rotation per minute. If you are using radian per second, the equation is this one. 4 multiplied with pi multiplied with the frequency supply over P. And this P also is actually number of pole. So I think we consistent, please be consistent lah. Kita pakai this one Okay, kita tak pakai ni We use this 120 multiplied with frequency supply over the number of pole And then this one is the in RPM. If you are using RPM, so please make sure that you use NS NS. If you are using units radian per second, please use omega S. So there's a difference. So that synchronous speed is actually what we refer is actually the speed of the magnetic flux at the stator at the stator. And that flux, kita ada rotor kan, dia akan induce voltage. Macam transformer, you ada flux linkage tu akan induce voltage betul dekat secondary. It will induce the voltage. Bila ada voltage and then you punya terminal tu you short circuit. Rotor tu punya tu short circuit, so bila ada voltage ada current. So that's why kita panggil induction motor. Okay? Because the rotor rotation is actually because of the induction from the stator, from the rotating magnetic flux tu. Okay, dalam video tu pun dah tunjuk lah. Okay. And then this one also another important equation which is what we call slip. Okay. So the rotation of the motor cannot equals will not equal NS will not equals to NR Tak boleh. It cannot equals. Kalau dia equal, the rotation will stop because there is no flux punya cutting. Okay. So the difference between the speed of the synchronous and the speed of the motor we call slip speed Slip speed. Either you can use in radiation per second or you can use in RPM unit. So this one is RPM So penting ni. Slip speed. Very important. And the ratio between the slip speed slip speed over the synchronous speed, yang ni adalah you punya slip speed. The ratio between slip speed and synchronous speed is what we call slip. Gelinciran And this slip, as mentioned in the video, is actually very, very small. Meaning that the difference between synchronous speed and the motor speed is actually very, very near. Okay. And this is the equivalent single phase induction motor. Where we have this one, this part is what we call stator. And this part we call rotor that has been transferred at the primary side. Dia macam transformer jugalah. Kan? Memang transformer pun dia punya principle pun. Cuma dia ada rotation. Okay, so RS is your stator winding resistance. And LS is your stator leakage inductance. The same case goes to the rotor side. We have the rotor internal resistance. And then you have also LR, the leakage inductance of the rotor. And then you have LM ni. Tak tahulah dalam circuit theory atau you fundamental, you punya lecturer sempat ajar tak ajar. Mutual inductance. Mutual inductance is actually the inductance that relate the primary and the secondary. Okay. The linkage. So you have IS and then you have IR. Okay. So this is actually what we call a single phase equivalent induction motor. Okay, single phase We assume that even though it is a three phase, but we assume that the other phase are equals. So we only concentrate on analyze only using single phase. And then at this part, very important, this one also, I want to highlight this one. This value of resistance here, which is R rotor over S. Meaning that this value of the resistor is depends on the value of the slip. Okay. So this is the power equations on the rotor side. So this is actually the power air gap. The power that has been transferred to the rotor. Power air gap is actually the power that kat sini lah. Kat sini. Okay. That transfer So the total power that has been transferred to the rotor can be computed based on this equation. Okay. 3 multiply with current multiply with resistance. Betul tak? From this equivalent circuit, as you can see, the current IR multiply with the resistance. IR kan? I multiply with, sekarang dia punya R is R over S. So that's why you got this. Okay. 3 multiply with IR square multiply with the resistance. The resistance value is R over S. Why we need to multiply with 3? Because this is a 3-phase system. Okay. And this one can be divided actually into two sub power, which is this one. 3 multiply with IR, I squared R is actually the power losses. Power loss due to internal resistance. Internal rotor resistance. Sebab rotor tu winding dia ada resistance internal. Kan, setiap benda there is a internal resistance. So you can use this equation. And this is the power output. This is the power that rotate the motor. Which is you can compute by using P out is equals to 1 minus S P again. Meaning that kalau power flow, you punya this one is your power again. This one is your P out. So you have a P losses lah, which is P rotor. Yang ni P rotor okay. P a gap. So the losses due to the internal resistance of the rotor, and the P out which is 1 minus S P a gap. Ngantuk, saya mengajar ngantuk. Oh, dah setengah jam dah. Okay, understand this one? Tak apa, yang ni masih lagi tak critical lah. Sebab nanti kita akan revise balik. Next week. Okay, this part 1 Part 1. Oh, ada lagi. Okay, so this one mechanical power, which is P out lah, kan? P out, which is torque multiply with the speed of the rotor. Okay, yang ni torque is actually the torque that produced by the motor lah. Okay, so this one equation, this one okay lah. I will not elaborate lah. Okay, and then finally, you will have this torque versus speed. Torque versus speed. Torque versus the speed. You will have this kind of characteristic. Okay, yang ni if you plot, you will have this one. Apa maksudnya ni? So this one is actually speed 0 from standstill. So it will actually the torque will start rotating, and then it will reach at the highest torque, and then it will go down. So in physical, saya nak sharekan video. Sebenarnya this one you have been dedahkan lah dekat dalam lab, tapi lab mesin you masa tu virtual online kan. Tapi ada video kita buat. We made a video. So saya nak terangkan video yang mana satu rasanya. Ataupun you tak perasan langsung. Do you perasan tak this punya karakteristik sebenarnya you nampak dalam video tu. Tapi tak tunjuklah graf ni. Okay. So saya nak tunjukkan video tu. Pelakon dia dah tahu kan? Pelakon dia siapa? Bukan Dr. Awang kan? Mana video tu? induction motor template. This one induction motor lah. Okay. Actually show the specificity. The mengaum tu okay. Okay, so this is the characteristic of the induction motor. Okay, but we didn't operate our motor at this part. We didn't operate our motor at this part. Do not. Okay. Start up, yes. You need to start up. Saya akan ada, ini akan mau sekejap lah. Oh, this is actually the area where we always operate our motor is actually at this linear region area. Kat sini. Okay, this small part. Pada sana contoh. Okay, only at this linear part only. We didn't operate at this non-linear part. So meaning that your control of the motor will always maintain the operation at this region. So this one is, you can see is actually synchronous speed here, the speed of the synchronous speed, and this is actually depends on your torque. For example, if my torque load is actually here, linear torque, and then my intersection is here, so my speed, my motor will operate at this speed. Okay, it depends on the load. Okay, kalau you punya load tu, torque tu kat sini, so the intersection kat sini, maknanya the motor will operate. This value. Okay, it depends on the torque. Okay. So how to control? So we are using the inverter. We can actually, okay, by using PWM, and then we can also control the frequency output. Okay, by controlling the frequency of the, then you ada PWM ya. You punya frequency output is actually proportional with the frequency of the load. Kalau you want the frequency to change to 50 to 100 Hz, then you need to change the frequency modulating. What is the frequency modulating? Sinusoidal. Okay. The sinusoidal is the modulating signal. This one is the carrier, FC. This one is your FM. Okay. If you want to change the output, then you need to change the frequency of the sinusoid. So that's why you can have, tadi yang dalam video kita cakap, how to change the speed. How to change the speed? You need to change the frequency supply. Kalau tak ada inverter, how can you the TNB to change 50 Hz punya frequency? Dia punya motor satu ketul, ni nak suruh TNB tukar. Daripada 50, bukakan 100, saya nak tukar. Saya tak nak macam ni, saya kena katakan frequency 100 Hz. Itu impossible lah. TNB nak entertain you kan? Banyak lagi customer lain. Okay?
So that's why in 1950, even though you have DC motor and AC motor, even though they know AC motor tu lebih bagus, it's better, kan? No low maintenance, tak ada magnet, tak ada brush nak boleh tukar setiap kali, kan? But because of to control the speed, to control the frequency supply, which is masa-masa tu kita ini tukarkan frequency, kan? That's why they opt for the DC motor at that time. Because DC motor senang. They change the speed by controlling the voltage. Senang je, kan? Tak tukar, tak ada apa. DC motor tak ada. Tak ada apa, there is no problem. Induction motor, the problem is to change the speed, you need to change the frequency supply. How come? It's impossible at that time. But by using the inverters, where the inverter can actually change the frequency band. So by, for example, this one, by using PWM, you change the frequency output by changing the frequency modulation. No problem. So that's why I think Salah 100% is most of our, for the industry, they are using speed of DC motor. Okay. So they are, depending on the control, on the leading system now. So we of system, whether to use a square wave, 6 step. Sometimes we call 6 step. This one is a square wave, maknanya dia pakai square wave. Or using PWM. But this one is much better lah compared to the square wave. Okay, so this is configuration of system, configuration of system. So by using step, 6-step voltage source inverter, this one square wave. In square wave inverter, we know that you cannot control the voltage, right? V1, you cannot control, Betul, You cannot control, betul. What does it? So how can we control the magnitude? We control from the rectifier. I mean that from this AC supply, the output here, which is DDC, we already control it by controlling the alpha. This alpha we control the amplitude. Because in AC motor, there are two methods, there are two parameters that you to control in AC. This is the magnitude, this is V1, and the frequency F1. These are two main parameters of electrical part. Okay, so how to control V1 for square wave inverters is by having this by controlling the alpha. So meaning that you have DDC is already controllable, and you use these inverters just to control the frequency. Separate. It has a separate circuit. Faham, Dalam AC motor, there is two parameters, the voltage and frequency. Kenapa pula voltage dan frequency? Tadi kata speed dia frequency saja. Okay. Kalau DC motor apa dia? DC motor. Voltage, kan? Voltage supply proporsional dengan speed. And then I supply proportional dengan. Okay, so right now, AC macam mana pula? Okay, AC motor, speed and torque, how to control? The speed tadi, frequency, supply. Torque. Torque is susah sikit. Ini over X. Betul kan? Torque is V over X. Bukan V, bukan direct V. So V supply over X. Okay. So that's why, as you can see, we are using square wave. Selalu kita tahu kita tak boleh nak control G kan. So what we do is actually rectify. Controlling the alpha, then you can get controllable. And then we use square wave inverter just to control separate. So bila ada when you have a two separate system, so means that ada banyak losses lah. There will be a losses. We have a losses at this rectifier circuit, and then we have losses at okay. We want to buy well. Okay. Kalau nak kejar voltage, okay. So as you can see, the voltage and the frequency are controlled by the inverter itself. Okay. So because V1 can be controlled by using and your frequency also can be controlled by controlled by frequency module. So both voltage and frequency can be controlled from the PWM inverter. So meaning that this rectifier just used for convert from AC into a much easier lah. Okay. We didn't have control on this one. So all the controls are being applied at the PWM inverter. So there's a difference if you are using PWM inverters and also square wave inverters. Okay. This is simulated result from the PWM output. It's a passive modulated. Okay. So actually, we have all the parameters that we have already learned for the inverters are really applied here. Okay. So I think that's all for today. So next we will go, I think, for AC Moto Drive. For easy understanding, we will go for the example calculation. Okay. So we will again next week, inshallah. Right? This Thursday, sorry. Tak sana. Kelas aku dia kelas. Kelas. Minggu depan lah kan? Minggu depan dah kan? Ha? Kita ada minggu depan dah pelang kan? Ha? Sekarang minggu 13. Right now, this is a 13 week 13. So, next week is the last week lah. Kan? Minggu 12 kan? Tak sangat nak decline. Tak apa. So, because I dah set semua, so actually next week will be the saya dah set, sebab saya dah ingatkan ni 13. So, saya dah plan kan, minggu 13 kan? Minggu ni. Kata minggu 12. Kalau saya ikut kalender saya mungkin 17. So you punya you ada kuliah berapa? 15 minggu kan? 15 minggu lah. Sekarang ni ada 2 minggu, ada lagi 2 minggu. Tapi tak apa, saya plan memang minggu depan lah. Minggu depan lah. So, and then you know that your final exam is very, very early. Right? So I think for 1 week you can have your own division. So if you don't understand, then you can come to me lah. 1 week tu kan? Memang risau. When? 5 of July. Ni kita dah dapat dah. Nampak airline nanti. Airline dah dapat dah. Nah, airline. Sini. Ha? Really? Kau punya apa? Ha? Di bawah? Oh. Okay, I think that's all. Okay. Thank you very much.